This is the Royal Air Force training centrifuge at Farnborough, and the team here are going to push me as far as they are allowed to push a civilian.
The centrifuge has been here since 1955. The device was originally installed for research purposes, although these days it's used for training as much as it is for research. And what it does is recreate the forces that you feel in an aircraft. For our routine pilot training, the first time pilots go on the centrifuge, we expect them to get up to 5G without a G suit and then up to 7G with an anti-G suit.
Now, I'm not taking a significant risk here. I'm healthy, I've pulled a few Gs before, and the human body can take this. And the reason we know that is because in the 1950s, the US Air Force used rocket sleds to push volunteers to incredible speeds. But that rocket-powered acceleration wasn't the dangerous or even the really high G part of the test. See, high G acceleration takes a lot of incredibly expensive rockets or a big old centrifuge like this. But high G deceleration, all you need for that is a wall. Or for something less destructive, like the rocket sleds, you use scoops dropped down into a water trough. US Air Flight Surgeon John Stapp, aboard the rocket sled Sonic Wind No. 1, holds the record for the highest sustained G-force anyone has ever voluntarily endured, 25 G for 1.1 seconds, with a brief peak over 46 G. And he was badly injured, but he survived and he recovered, and he lived to the age of 89. The human body is an incredible thing, particularly because we didn't evolve for this.
G tolerance is something that's innate in all of us. Some of us have high G tolerance, some of us have low G tolerance. Over the years, people's G tolerance doesn't really adapt. Any shortfall in G tolerance has really got to be made up by physical exertion in the G straining manoeuvre.
What the centrifuge doesn't have is much jerk. And jerk is a technical term. In the same way that acceleration is the rate of change of speed, jerk is the rate of change of acceleration. And because it takes time to spin up and spin down, oh, here we go! Even though the acceleration is high, the jerk here is relatively low, about 1 G per second. Jerk is the difference between a rocket to space, which might take a couple of minutes to reach peak acceleration, and a fighter jet, where manoeuvres might change the G-force acting on you in a fraction of a second. And it can go further than that. You can measure the rate of change of jerk, which is called snap or jounce. The two derivatives after that are called crackle and pop, but they're not all that useful in the real world.
As we increase the G that Tom is exposed to, the blood's going to be pushed down into his feet, and he's going to have to work really hard to push that blood back up to feed oxygen to his brain to keep him conscious. And in real life, we would be expecting that person to be flying an aircraft whilst doing that.
I'm getting a little bit of grey out, I can't quite see.
We teach the anti-G straining manoeuvre, which composes of two separate parts. First of all, muscle tensing, so both the buttocks and the legs, squeezing the blood vessels to try and get the blood back up into the chest and the head. But also the second part is a breathing manoeuvre, which increases the strain in the chest, directly increasing the blood pressure to the great vessels in the chest and keeping him conscious. And when you lose blood pressure to your head, you could even lose consciousness, and we term that G-induced loss of consciousness, or G-lock.
Blimey, I lost everything there. Wow.
G-lock in itself is not dangerous, but the real point is when you G-lock, you're flying an aircraft. So if you're not able to fly that aircraft, I'm sure you can appreciate that that is a real problem.
Air Force fighter pilots can experience force on their bodies that most of us will never even come close to feeling. To get ready, they practice here, in the Air Force's human centrifuge.
We're at Brook City Base, and this is the centrifuge. This is what we use to train our pilots on G-forces. G-forces are pretty much, if you've ever ridden a roller coaster, you kind of get that feeling your stomach's about to come out of your mouth. That's kind of what G-forces are.
G-forces are forces caused by acceleration, and pilots experience them during sharp turns. The tighter and faster the turn, the greater the G-force. They call it pulling Gs. To help them learn to pull Gs safely, the Air Force does high G training on the centrifuge. Before training, the pilot gets checked out by a doctor and then fitted with an anti-G suit. It's like a giant blood pressure cuff that keeps the blood from pooling in his legs.
G-forces stand for gravitational forces. We're at 1 G right now. That's actually what keeps us from floating into outer space.
Pilots can experience over 6 G when they fly. That's 6 times the force of gravity.
If I was at 6 G, my body would feel like if I weigh 100 pounds at 6 G, my body will now weigh 600 pounds. If my hand weighs 10 pounds, at 6 G it's 60 pounds now. You can actually see how difficult it would be for a pilot to flip a switch here and has to do a lot of other things while pulling back on the stick.
Sometimes the G-forces are so strong that pilots can lose consciousness. They call that G-lock. So before they fly, they practice methods to avoid G-lock in the human centrifuge.
Legs tight, deep breath. On top, breathe. 1, 2, breathe. Okay, relax. Okay, stand by. We're gonna set the limits for 5G, 30 seconds. And 3, 2, 1, engage. Legs tight, deep breath. Hold it. You're on top, breathe. 1, 2, breathe. 1, 2, breathe.
As the centrifuge spins, the pilot's body is trying to go straight, but the direction is constantly changing. This pushes the body outward. They call it a G-force, or gravity force, but it's actually a measure of acceleration. Acceleration is the change in velocity over the change in time. Velocity is determined by both speed and direction, so even if the speed stays the same, because the direction is constantly changing, there's acceleration. This outward force is called centrifugal force, and it's expressed as a multiple of G. An untrained person might black out between 4 and 6 G, but a trained pilot wearing an anti-G suit and using the straining maneuver can go up to 9 G in the centrifuge, just like this pilot did today.
One simply does not mess with the A-10 Thunderbolt and get away with it. Call her the A-10 Thunderbolt, or more affectionately, A-10 Warthog, but the U.S. Air Force Close Air Support Avenger will take a beating and still find a way to shower you with her low-altitude armor-piercing ammo. The A-10 is one of the most revered pieces of equipment that our fighting men and women have at their disposal.
Too much air on this one, so it's half the time, alright? Sounds good. You ready to go, sir? 1 step. Alright, let me know. Okay. I can go down there. Keep running, leg, breath, back. Yeah, it's getting a little dark. Where at? Over here. I mean, we're at the right, I'm sorry. Oh, sorry. So halfway through? Yeah. Halfway to get it back? Starting to, but... What's good to get it back? Oh, what's good to start to get it back? Start to get my butt. Okay. Butt more. How much percentage is that, you know, right? Is it 20, 30? How much? Would you lose? Start losing the green? Start losing the green.